A fair coin is tossed and a fair die is thrown. So you have a coin and you have a die. You know the the sample space for a fair coin and a sample space for a die. So you have a coin which has a head and a tail, and you have a die which has 1, 2, 3, up to 6. Now, which of the following is the sample space for the combination of these two experiments simultaneously? So, looking at which of them do you think will be the answer? Is it A, B, C, or D? Okay, I have a hand up. Okay, go ahead, Kwame.
So I think D. D is the answer.
Okay. Is there any other alternative answers? Do you all go with Kwame? Yes, so the answer is D because in a coin it will either be a head or a tail, but with the die it will be 1, 2, 3. So when you throw it fine, it's possible or two and a head. Then we'll do that to get to six and a tail, then six and a head. So the B is not correct because it is not any of that. It's not either one or this. No, it's two of them. One a tail, a coin, and one a head, a die. So the answer is D. Thank you. I hope we are all okay with that. So you do permutation. I also told you that most of the time when we have events and we use for probability event, we can use intersection or comma. So if I have a coin which is given a sample space of a head and a tail, and a die will give you 1, 2, 3, up to 6. So this and this, this and this and this and this. We take the head with all 1, 2, 3, up to 6, and the tail with 1, 2, 3, up to 6. That is what we display over here. So the answer is D. Thank you. Then question 2. A fair coin is tossed and a fair die is thrown. Let A be the event that a head is observed, and B be the event that an odd number is observed. What is the probability of A and B? A intersection B. So I think the first question should help you to answer the second one. So knowing your your sample space, which is your D, we should be able to look for the odd event H and the odd event. So how many event that has a tail, a head, and also an odd number? An example, this is 1. And which one again? We have 3H, that is 2. We also have 5H. So what will be our answer? Hello? Okay. Yes, Vida first.
The 1/2.
1/2. Let's also find out from Boyne Kwabena.
Yeah, so the answer is this 1/2.
Okay, what about 2? Enoch.
1/4.
1/4. Any other different answer? So we have 1/2 and 1/4. The answer, we have how many times, the numerator is on 3 possible outcomes. 1 and h, that is 1. 3 and h, that is 2. And 5 and h, that is 3. And the denominator are how many? It's 12. It's 12. This is 1, 2, 3, 4.
Sir, please, is the old one. Sorry.
Okay. Thank you. Are we okay with that? 1/4 is 3 out of 4 possible outcomes. Three out of 12 possible outcomes. So it's 1/4. Okay, Pascal, thank you. Let's look at question 3. Ray is a basketball player who takes 4 independent free throws with 70% probability of getting a basket on each shot. Let X be the number of baskets Ray gets. What is the probability that he gets exactly 2 baskets? So in question 3, what experiment are they describing here? X will follow what? X will follow binomial with n equals to 4 and p equals 0.70, 70%. So it means that the probability that what? X equals to 2 will be equals to 4 combination 2, 0.7 to the power 2, and 0.3 to the power 2, and 4 minus 2 is 2. So that is what you are going to so calculate that probability and let me know. Pascal, thank you. Yeah, so what will be the answer? I don't have calculator with me, so you have. So put your answers on the chat session. Okay. Pascal giving us D. Joshua D. Good. 0.265. Okay. D said okay. Thank you. Desmond, Moses, Monica, Vida, all of you, thank you, Kwame. Great. The good thing is that if you don't participate, if you don't practice, you will not be used to it. You will not be able to what? You may even forget. So if you go and meet in an exam, you don't need to worry yourself again. You only will know that, yes, I calculated this. This was the final answer. So off you go. Is that okay? So please let us all involve ourselves in this exercise. Thank you. Let's go to question 4. A random variable x has a Poisson distribution with a mean of 0.4. What is the probability that the random variable is greater than 0? So since the x follows Poisson with a mean 0.4, it means that your rate is 0.4. So your probability that x greater than 0 just be equals to 1 minus the probability that x is equal to 0. So we are going to have what? 1 minus, our Poisson has lambda 0.4 to the power 0, e to the power minus 0.4 over 0 factorial. So this will be 1 e to the power minus 0.4 over 1 from 1. So what will be your answer? Kindly calculate that. So we have A to be 0.40, B 0.50, C 0.67, D 0.33. Okay, the first answer has come. Any other? Okay. Oh, great. So when we compute, we are going to get 0.33, which is the D. Oh, that's great. Thank you. We are making progress. I hope the question, the explanation is well cleared, well understood. Please, if you have a question with the explanation, kindly let me know while we proceed. That's why we are here, so that we can able to understand. Let's look at A5. A bag contains 15 balls distinguishable only by their colors. 10 are blue and 5 are red. GKD reached into the bag with both hands, pulled out 2 balls, one with each hand, and recorded their colors. Express the event that the ball in his first hand is red as a subset of the sample space. So the first thing that we need to do is to what? We have a bag containing what? 15 balls, distinguishable only by their colors. 10 are blue and 5 are red. So what it means is that we have 10 B and 5 red. So what are the possibilities that you can get? It's possible that the first one, expect the event that the ball in his left hand is red as a subset of the sample space. So if the left hand, let's assume this is your right hand and this is the left hand. So the right one can be what? Red, and the left will also be red. So you can have red, red. Or you can have what? Blue, red. So this will be the possible, and your sample space will be red, red, or red, blue, or blue, red, or blue, blue. So your sample space is what we can get here. So as a subset, then which of these are we? This is we have either red, red or blue, red. If your first one is your right one and second one is your blue, if the first, okay, let's assume if the first one is our right left, and the second one is as we face the distance. Then we'll have what? Red, red, and here will be red, blue. The first possibility will be red, red, the second one will be red, blue. So that is what we are having in A here. So you have red, red, or red, blue. That will be your subset of your universal set, which you have red, 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 blue, blue, red, and blue, blue. Are the possibility that both hands can able to pick. So your answer will be what? A. Joshua, sorry, your network is disturbing you. Sorry for that. So are we okay with this? So the second one cannot be because what? You have red, blue, and blue, blue. A third one is just red, red, and the last one is red, blue. So your possibility that one, the left hand should be what? Red, and the second hand can be blue or can be what? Red too as well. Is that okay? Good. Let's look at question 6. Suppose Godwin throws a die repeatedly until he gets a 6. What is the probability that he needs to throw more than 10 times to get a 6? In the first place, the experiment described here is what? 6. What is the experiment we are describing here? Can you write it on the column section? On the chart section? Yes. Okay. So thank you. It's a geometric distribution. You are throwing till you get a success. So Pascal is not binomial, but rather geometric as stated by Emmanuel, Benjamin, and Kwame. So thank you. So it will be a geometric distribution. So if it is a geometric, then we are saying that X will follow a geometric with a probability 1/6. Because a die has 6 independent sides, and each of them has equal likely outcome. That's 1/6, 1/6. So that's what you have. So we have to find the probability that the 6 occurs more than what? 10 times. We need to throw more than 10 times to get a 6. So you have to find the probability that X is greater than what? 10. Which will be equal to the summation S equals to 11 more than 10 to infinity 1/6 5/6 to the power what? X minus 1. So what will be the answer if you simplify this? Can you calculate that the summation X equals 11 to infinity 1/6 5/6 to the power X minus 1, because we are doing more than 10 times. So the next one can be 11. 11 one can give you the answer, or 12 or 13 or 14 or 15 or 16. So what will be our probability? We learn this. Your first term here will be, this is 1/6. More summing from the first term will be 5 over 6 to the power 10 divided by 1 minus common ratio will be what? 5 over 6. So you know directly this, the denominator will cancel this, so we are left with what? 5 over 6 to the power 10. And what will be that? Can we calculate that? So we'll have 5 over 6 to the power 10. Please use your calculators. Okay. Thank you. Wilbert, good. Desmond, thank you. Prince, thank you. Jamesi, Desmond, so thank you. Vida, thank you. So our answer will be A, which is 0.161. That's great. Is those who have not been able to put them there, do we understand? Okay. Question 7 says that two players, Samuel and Bernard, play a tennis match. The probability of Samuel winning the match is 0.62. What is the probability that Bernard will win the match? Two players, Samuel and Bernard, play a tennis match. The probability of Samuel winning the match is 0.62. What is the probability that Bernard will win the match? So when they play a tennis ball, how many possible? Okay. We have 0.38. Are we sure? Let's analyze it together, please. So when we play tennis, we have two possibilities, either win, lose, or draw. So we are saying that what? If Samuel winning is what? 0 point what? 62. Then we should find a probability that well, he will lose. Or he will not win, a probability that he will not win. So he will either lose or he will draw. If he draw, he has not win. Is that okay? So we can have this. This is where Bernard wins. This is where Samuel wins. And this is where they both draw. Okay. So we'll have, let me see. A minute, eh? Okay. So here they were considering only two possibility, win and or lose. There was no light draw. So we'll go in for the B, which is what? You subtract the complement from that, that will be 0.38. So thank you. If they were to give us the possibility of draw, then we can able to get that of the complement of that. So here they were only looking at without the draw, only the winning and losing. So thank you. Okay. So 8, what is the relationship between the binomial distribution with parameters n and p and the Poisson distribution with parameter lambda? We learned approximation, binomial approximation to Poisson, and we said that what if your n is what large and p is small, then your lambda will simply be equals to what n times p. So that's the relationship B, which we should know. So based on that, your lambda will be n times p, not what n over p or n times lambda equals. Okay. So we have to find the probability that is a head given that is originally what? Also a head. When it was a head, condition that it is also a head. So it's a two-tail. It has two heads. So this will be equal to the probability that what is a head, a two-tail head, head, that over the probability that what is what a head. So it's a head. condition that the first one drawn that was a head. The first side was a head. So with the one with two heads, if we are looking for this one, it will be from a what's the probability here? It will be this times what? The conditional probability. So you have P that's 1 times 1 over 10. 1 over 10 times 1, which is 1 over the probability that it is what? 0.5 times 0.9. So you have 1 over 10 times 1 over the probability that it is what? 0.5 times 0.9 plus the denominator is 1 over 10 times 1. That's 0.1. So you multiply indirectly. I'm having, oh, let me clean this. The denominator is times the probability that what? Okay. So we are getting 1. So this is 0, 9 over 10. Then here we have what? 1 over 10. So if he randomly takes one of the coins from his pocket, what is the probability that it is the coin with two heads? So here we have tail and here we have head, and this one give us 1 and this one will give us 0 because for two heads it hasn't gotten any tail, so the tail content will be 0, so this one will be 1. Here it is a tail and a head, so here will be 0.5 and here will be 0.5. But the probability that it is two heads, meaning that what? The first one was a head and the second one also was a head. That will be what? This times what? This probability here. That will be what? 1 over 10 times 1. So the probability that the coin that you pick is what? This thing will be two heads will be what? 1 over 10 is a head. So that will be this one. and the other side here, this thing was a head. So that will be also this times this. So you have this of 1 over 10 plus 0.5 times 9 over 10. So the denominator, I am going to have that be what? 20. That's 2 plus 9. 11 over 10 over 20. We have been dividing. Oh. Okay. Oh no. Okay. So you'll be getting 1 over 10. It's only one-sided plot that we should be getting. I was thinking we're supposed to apply this rule to it. That is a base rule, but we only have to find the probability that it is HH times the probability that it is what H, condition that it is H. And that will be 1 over 10 times 1. That's 1 over 10. So that will give us as 1 over 10 as C. Okay. So it 10 says that Dennis is a soccer player who takes 8 independent free shots per game with a probability of 0.7 of getting a medal on each successful shot. Compute the expected number of medals that Dennis will receive. So with this one, we have n equals to 8 and your p equals 0.7. So since it's only 2 possible outcomes, either he wins or he loses. So your x will follow binomial with n and p. So your expected value of x will be equals to n times p. So what will you get? What will be the expected number of what medals you get? You multiply 8 times 0.7. And what did you get? Is the answer C? Okay. 5.6. Thank you. Then 11. There are 18 girls and 12 boys in the class. There is 2 over 9 of the girls and 1 over 4 of the boys walked to school. 2 over 9 and 1 over 4 of the boys walked to school. One of the students who walked to school is chosen at random. find the probability that the student is a boy. So for us to be able to do that, it's important you draw your tree diagram. Which looks like this. So I have 18 girls and 12 boys. So that would be 18 over 30. This is for girls. And for boys, I have 12 over 30. And those who work for boys is those who work and those who take car. This one is 1 over 4, and this one will be 3 over 4. And for girls too, we also have those who work as 2 over 9, and those who take car will be 7 over 9. So find the probability that a student is selected, a student is a boy. So if it's a boy, it's a boy, given that he walked to what? School. So that would be the probability that he's a boy, he walked to school, given that he's a boy, given that he walked to school. The sum of that by total probability. So for your numerator, I have 3 over 1 over 4 times 12 over 30 divided by 1 over 4 times 12 over 30 plus 18 over 30 times 2 over 9. That would be the probability that it's a boy, given that he walked to school. So multiply 1 over 4 times 12 over 30 divided by 1 over 4 times 12 over 30 plus 18 over 30 times 2 over 9. That will give us our probability for that. So what would be the answer? Can you calculate that and give me the answer here? One over 4 times 12 over 30 divided by 1 over 4 times 12 over 30 plus 18 over 30 times 2 over 9. So the denominator is 1 over 4 times 12 over 30 plus 18 over 30 times 2 over 9. Then the numerator is 1 over 4 times 12 over 30. So that should give us the probability that it's a boy, given that he walked to school. Yes. Yes, we are in question 12. Paul. The question is here. There are 18 girls and 12 boys in a class. There is 2 over 9 of the girls and 1 over 4 of the boys walk to school. So that's what we have here. We do our tree diagram where one leg is for girls, one leg is also for boys. So the number of boys is what? The probability of choosing a boy is what? 12 over 30. The probability of choosing a girl in that class is 18 over 30. Then out of the total number of girls in the class, which is what, 18 out of 30, the probability that the one who walk is 2 over 9, and the probability that those who take car is what? 7 over 9. When it comes to the boys, those who walk is 1 over 4, those who take car is 3 over 4. And they're asking that what? One of the students who walk to school is chosen at random. Find the probability that the student is a boy. So we should find the probability that it's a boy, given that he walked to school. And by using the Bayes theorem, the probability that he's a boy, given that he walked to school, will be equals to the probability that he walked to school times the probability that he's a boy, given that he walked to school. Oh no. So the probability that he is a boy times the probability that he walked to school, given that he is a boy, over. So the numerator is supposed to be this, sorry. But the probabilities are the same. The probability that he's a boy times the probability that he walked to school, given that he's a boy, over the probability that he's a boy, given that he walked to times the probability that he walked to school, given that he's a boy, then plus the probability that he is a girl times the probability that he walked to school, given that he is a girl. So your numerator is 1 over 4 times 12 over 30. The probability that he's a boy is 12 over 30. The probability that he walked to school, given that he's a boy, is 1 over 4. Then the denominator is 1 over 4 times 12 over 30 plus 18 over 30 times 2 over 9. So when you do that, I think by numerator I'm getting 3 over, so that's 1 over 10 divided by, this also give me 1 over 10. And here, plus 2 here, 4. 30 here, that will be 15. So I'll left with 2 over 15. So 1 over 10 divided by 1 over 10 plus 2 over 15. So simplify that, what did you get? The LCM here is 30. So here will be 3 plus 2. So that's 5 over 30. So I have 1 over 10 times 30 over 5. Is that correct? Yes. So 5 here, 1, 5 here, 6. 6 here, 3, 6 here, 2 here, 3. This will be 5. So do you have that? Three over 5. What did you get? You had 3 over 7, eh? Okay. I got a maybe my calculations are wrong. That's why. So what I'm saying is that this is the probability that he's a boy. It's just 12 over 30. The probability that he's a girl is 18 over 30. So this is 9 over 15. And this is 4 over 10, which can also be expressed as what? 2 over 5. Then here 3 over 5. So your probability that he's a boy, given that he walked to school, will be equals to 2 over 5 times 1 over 4 divided by 2 over 5 times 1 over 4 plus 3 over 5 times 2 over 9. So that's what I mean. So the numerator, we are getting 1 over 10 as what we had, and the denominator, this is 1 over 10 plus, and this will give us that's 2 over 15. So simplify that 1 over 10 plus 2 over 15, then 1 over 10 as the numerator. Is that what you did and get what? 3 over 7? Hello? Okay. Thank you. Then okay, thank you for that. To also say, suppose that a discrete random variable x has a probability mass function given as this. What is the value of the probability that the random variable x is even? What is that is this probability? So we should find a probability that it is even. So we are only to sum for even terms up to infinity, meaning that we are summing the probability that x is equals to even. That's a multiples of 2k, which will be k equals to 1 to infinity, 1 over 3 to the power 2k. So indirectly, we are summing k from 1 to infinity, 1 over 9 to the power k. So the first term will be 1 over 9, and your common ratio will be 1 minus 1 over 9. So indirectly, we are getting 1 over 9 divided by 8 over 9, which end up getting what? 1 over 9 times 9 over 8. So that's 1 over 8 as the probability that is even. It's not 1 over 3. Daniel, it's 1 over 8. Here, K equals 1, 2, 3. So you have to find K to the power 1 over 3 to the power 2K. So when you raise 1 over 3 to the power 2, you are getting a 1 over 9 to the power K. That would be the probability of even terms. So you are summing all of them from what? K equals to 1 to infinity. So you are summing 1 over 9 to the power K. K takes value from 1 to infinity. And this is what it will give you. 1 over 9, that's the first term, divided by 1 minus the common ratio. And you are increasing by 1 over 9. So the denominator will now be what? 8 over 9. So 1 over 9 divided by 8 over 9 will give you what? 1 on 8. Is that okay? It also gives us a discrete random variable. X has a cumulative distribution function given by 0 for x less than 6. X between 6 and 10 is 1 over 4, and x greater than or equals to 10 is 1. Using the probability mass function obtained from this cumulative distribution function and calculate the expected value of x. So what you need to do is this. Get your probabilities. Your values are between 6 and what? 10. So it means that what? If I have this, and this is my 6, and this is my 10, I have a function x less 0 will be 0. Then it jump to this is 1 over 4. Then it jumps at this thing is 1. So this is what I have. So what you need to do is to find the probability at what? 6, the probability at 7, the probability at 8, the probability at 9, the probability at 10. So it jumps. So at 10 is what? Greater than what? This thing. So between all this is just what? 1 over this thing. So using the probability mass function obtained from what? This. So you have to find the midpoint of what? Of your value at between 6 and 10 and assign that probability to it. Then at what? 10, the remaining probability jumps to that. So it means that the probability at 10 greater or equals to be 1 over 6, 1 over 4 from that. That will be what? 3 over 4 will correspond to 10. Then from 6 to 9 is 1 over 4. So the mid value will assign that probability to it. Then you use that to calculate your expected value. So from here, it means that what? if you add the probability from 6, 7, 8, that give you these values. So you see from here, you get the same probability, that cumulative is the same. So when you cumulate from here, because this is a cumulative distribution up to here, before this one this is what you give you. So that's the cumulative probability between that range. So it means that what your probability for that point, you only have to add them. So you just take the mid value there. That will be what? Between 6 and what? 8 and 10. What is the value you get there? The mid value there. So you have 6, 7, 8, 9. 10 is not inclusive. So between that, we are getting 8. So 8 should give us the mid value. So you have 1 over 4 times 8 plus or 10 times the remaining one, which is 3 over 4. So when you add this, that will give you an expected value. What am I getting? So 1 over 4 times 8, approximately, I'm getting what? That is 2 plus 10 times 3 over 4. So this will give me 2, this is 5. So 15 over 2. Okay. That's 7.5. 9 point. So what should be getting should be B, approximately 9. So what we get the expected number of for this one will be approximately 9 as a probability, as our expected value, sorry. So 14, Rachel flips a biased coin. The probability that she gets 2 heads is 0.16. What is the probability that she gets 2 tails? So if you have a biased coin, it means that what? Head and tail is not equals to 0.5 and 0.5. So if the first toss is what? A head, and the second one is also a head. So the probability that you get a head and the second one was a head is 0.16. So it means that I'm going to get P, which is equals to the probability of a head, that is squared. So you have what? P squared is equal to 0.16. So your P, which is the probability of head, will be equal to the square root of what? 0.16. And that will be 0.4. I think 0.4. So the probability that he gets 2 tails will simply be equals to what? 0.6 times 2 squared. And that will give us B. That is what? 0.36. So that will give us 0.36. That is your B. Then, our questions are many. Okay, 15. Suppose that at a busy traffic junction, the probability P of any passing car involved in an accident is 0.001. During a certain time of the day, 100 cars pass through the junction. What is the probability of 2 or more cars being involved in an accident within this period of the day? So you are supposed to use a binomial approximation to Poisson to be able to calculate this probability. So we are giving our P to be equal 0.001. So you multiply 0.001 times the number of cars, that will be 100. So that will give you a lambda, then use your Poisson distribution to calculate that. What I want us to do is to explain some of the questions in section B so that we become more familiar how to tackle them since we have not done that. Is that okay? Hello? Because time is going. So the first one, section B, B1A, state the total probability rule and the Bayes theorem without proof. So here you are only to state that for a sequence of events, if I use this as my system where I partition it, and I have this as my B, and these are my A event 1, A1, A2, A3, A4, in that order, A5. So we are saying that for the total probability of B, which is this circle, is equals to probability of what? A1 times the probability of B given A1 plus the probability of A2 times the probability of B given A2 up to that. So our total probability just says that our probability of the sum of what? Probability of AI times the probability of what? B given AI. So that is your total probability rule. And the Bayes rule will now lead us to you only need a numerator over the total probability rule. So for the probability of what? A1 given B will simply be equals to probability of what? A1 times the probability of B given A1 over the total probability rule, over the total probability B. So this will be your numerator divided by the probability of B, which we are defining as the sum. So that is what we are just to state here without proof. Okay. I hope we have that in our notes, so it shouldn't be a problem. B, we are saying that a certain person considers that he can drink and drive. Usually, he believes he has a negligible chance of being involved in an accident. Whereas he believes that if he drinks 2 pints of beer, his chance of being involved in an accident on the way home is only 1 in 500. 1 in 500, that is what? 1 over 500. Assuming he drives home from the same pub every night, having drank 2 pints of what? Beer. What is the chance he is involved in at least one accident in 1 year? State any assumption made when assuming your answer. So here, you have to first look at what your probability is and what your events are, number of events are. So a certain person who believes that the probability of getting an accident when he drinks is very small. So whereas he believes that if he drinks 2 pints of beer, his chances of being involved in an accident on the way home is only 1 in 500. Assuming he drives home from the same pub every night, having drunk 2 pints of beer, what is the chance he is involved in an accident at least one accident in 1 year? State the assumption made when assuming. So here in 1 year, when he goes home every night, he drinks 2 beer bottle or pint. So you do that every day. So they have given the whole year. So how many nights would that be? Is that okay? So you are using what? Binomial. The chances that you get an accident is given to you 1 out of 500. So here you are going to use the binomial approximation to Poisson to solve that. So approximately how many now? That's 300 and what? 65 nights in a year. And your probability is 0, 1 over 500. So you multiply that to what you give become your rate and use that to calculate the probability that what is the chances that he is involved at least one accident in what 1 year? So the probability to be at least one will be what? Less than 1, that will be 0 or no accident at all. 1 minus no accident at all. So use the Poisson distance. And the assumption that you have to make is that each night is independent of the other. We assume that each night you drive home is independent of the other nights. And the chances of getting an accident each day is the same. And the chances of not getting an accident is also the same. So we apply the assumptions of the binomial independence and the constant probability to be able to do that. And we assume that your N is very large and we already know the P is small. So we use the approximation to be able to do that. So those are the assumptions that you can state. So in C, in a certain town, 30 See, in a certain town, 30% of the people are conservatives, 50% socialists, and 20% liberals. In this town, at the last election, 65% of the conservatives voted, as did 85% of the socialists also vote, and what? 50% of the liberals voted. So 60% of the executive voted, 82% of the socialists also voted, and also 50% of liberals voted. A person from the town is selected at random and states that she voted in the last election. What is the probability that she is a socialist? So here we are going to apply Bayes rule. You have to calculate the Bayes rule. So if the chances that the person voted will be given to us, that's what. We know the probability that is a conservative, socialist, and a liberal. Then the chances that the person voted as given to us. So we have to find the probability that what? Is a socialist, given that what? She voted the last election. So that will be equal to the probability that what? Is a what? A socialist times the probability that what, he voted, given that he's a socialist, over the total probability rule that we define at the top. That will be the probability that he's a socialist times the probability that he voted, given that he's a socialist, plus the probability that he's a conservative times the probability that he voted, given that he's a conservative. Then we have plus the probability that liberal times the probability that he voted, given that she's a liberal. The probability that she is a socialist is that's what we have here as 50, 0.5. The probability that he voted, given that he's a socialist, that is 82%, that's 0.82. So here will be 0.82 and here will be 0.5. So the same thing that I repeat at the first one, then plus. Here is a consecutive, that's 30%, that's 0.3. Those who voted, given that their consecutive is 65, to 0.65 times 0.3. Then when you come here, it's a liberal is 20%, that's 0.2 times those who voted as liberal is 0.5. So we have 0.2 times 0.5. When you simplify this, that will give you that probability here that we are to find. So we have this one as a 0.5 times 0.82 as your numerator. Then your denominator, we have this again, plus 0.3 times 0.65. Then plus those who are liberal, 0.2 times what? Those who voted as liberal, 0.5. So the denominator will be 0.5 times 0.82 plus 0.3 times 0.65 plus 0.2 times 0.5. That will be your denominator. That will give you a total probability. Then the numerator will only be this. That will give you the probability that she's a socialist, given that he voted last year. Is that okay? Okay, so that will be for question 1. I hope it's well understood. Good, I'm recording so we can get the recordings and we'll go back and look at it. Then B2, new orders for cement from a distributor of Gasem Limited vary in terms of the amount in Ghana cedis. In 2022, the following orders were placed. 0 to 1,000 were 20, 1,001 to 2,000 were 50 in that order. Find the probability mass function for the orders and show that it is a legitimate probability distribution. So all that I need to do for A to find the probability mass function, you are assuming you find the midpoint for the sales 1,000. This to the midpoint for 0 to 1,000 will be 500. Also 1,000, 1,001 and to 500 to 2,000. You find the midpoint for all this. That will give you your sales. Then here to get the relative probabilities, you add this 20 plus 50 plus 70 plus 50 plus 30 plus 4. That will give you a total frequency. Then you divide 20 by the total, 50 by the total, 70 by the total, 40 by the total, 30 by the total, and 40 by the total. So the fractions you get becomes your probabilities. So your values, the midpoint of this in thousands will give you your values, and your probability will be the values we get here. That's the regulative frequency by dividing each of the number of bags by the total bags. Then when you finish, you sum all that. If it is equals to 1, then we show that it is all a legitimate probability mass distribution. So that is B for A. Then B, compute the probability that a new order for cement will exceed 2,000. So if it will exceed 2,000, then what it means that we are going to add the probabilities of 70 corresponding to 70, correspond to 40, corresponding to 30, correspond to 40. So you add all the probability we got there, those fractions we got there, and that will give you the probability that the new order will be greater than what? 2,000. Which one should I go over? Benjamin and Desmond Jamesi? Benjamin Dako and is it B2? Yes, A. Okay. So please calculate for me 20 plus 50 will give me 70, plus 70, 140, plus 40, that's 180, plus 30, 210, plus this, that's 250. So 250 bags. So here we have your probability. So the probability that X is equals to maybe the value small x, the number of bags here, the sales here. So your sales will now be your values, and your number of bags become, that's what you use to calculate your probability, that's your frequencies. So here you divide 20 by 250, 50 by 250, 70 by 250, 40 by 250, 30 by 250, and 40 also by 250. So those fractions you get here, 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 here in a tabular form like this. And here we are going to divide what we add 1,000 divided by 2. Whatever it becomes your x, your sales value, midpoint. Then you also add 1,001 plus 2,000 divided by 2. That will give you your midpoint for this second group. Also the same here. So you find, as we learn how to find midpoint in what statistics in senior high school, the same way you add the lower plus upper and divide it by 2. That will give you the range, the value for that. So you find the midpoint for this, that will give you the individual values. And this will give you your probabilities. Then when you finish, all that I need to do is to add, to show that it is legitimate, you add the probabilities and find the total here. If the total here, total, which is equals, you find the total here, this is 250. And if the total here is equals to 1.00, then means what? We say that it's 11 because the probabilities of the various value sales is given to 1. So it means that your probability mass function is legitimate. Is that okay now? I hope my explanation is better now. Okay. So the B what I said, I calculate the probability that a new order for cement will exceed 2,000. So if it exceeds 2,000, it means here is 2,001 to 3,000. So the order exceeding 2,000 will be after this level. So you add the probability here, that's 70 over 250 plus 40 over 250 plus 30 over 250 plus 40 over 250. The sum of this from here to here, 1, 2, 3, 4 probabilities, will give you the probability that the new order is greater than 2,000 Ghana cedis. Is that okay? It's greater than 2,000 cedis. So C is a calculate the probability that a new order will be 3,000 or less than given that the order exceed 1,000. So we have to find the probability that the order will be 3,000 or less, given that it will exceed the order exceed 1,000. So we have to find the probability that x is less than the order is less than 3,000, but given that x is greater than 1,000. So if we are to find this, it becomes the probability that between greater than that will be here and here, here and here. So this and this. So you add this plus this. The probability that the order is greater than what? Is 3,000 or less. See this, and given that it's greater than this. So the probability that it is greater than what? 1,000 if adding the probability from here up to this point divided by what is common here, their joint probability, less or that. So that will be this plus it divided by the total probability from here to here. So this is a conditional probability given to here. So we have to express that as this. So this becomes the probability that x 1,000 is greater than 1,000 order, but x is less than 3,000. That's or equals to 3,000 divided by the probability that x is greater than 1,000. So that's all. So you add the probability for corresponding to 50 and corresponding to 70 over 250 divided by from just after 20 from 250, that will be 230 over 250. So I'm going to have 120 divided by 250 all divided by what? 230 divided by 250. So your probability now will simply be equal to 120 divided by 230. So 12 over 23 will be the probability that x, the sales is greater or less than 3,000 cedis, but given that it's greater than 1,000. So you have to apply a conditional probability to this. Okay, thank you for your continuous support. So with this one, we need to remember and apply conditional probability. So it will be equals to 70 plus 50, their division by 250, that will be equals to 120 divided by 250, all divided by 230 divided by 250. So in that, we'll be having the probability of what? 120 divided by 230. This will cancel. We'll have 12 over 23 as C. Okay. D. Calculate the expected amount for new orders and the standard deviations. So the expected amount for new order. So what we need to do here, that is why we calculate the mean point, the midpoint. So you take the midpoint times the corresponding probabilities that we have divided here. So this will be 500 times this probability here. Here to the midpoint times this probability here, the midpoint times this probability, the mid value times this. When you finish, you add all of them. That will give you the expected value. Then you have to calculate the standard deviation. So you need to calculate the variance to before it is. So what you do there, you subtract the mean from each of those mid values before you score it. Then you sum the deviations and divide it by n minus 1. And how many are there? 1, 2, 3, 4, 5, 6. Is that okay? So that will be your n. So your square, the difference square divided by n, that's n minus 1, 6 minus 1. Okay. Then find the square root of that. Then briefly interpret your result in D above. Your D result is the expected amount. That's the expected amount that one need to be able to purchase or order bags of cement. Whilst the standard deviation measure the average spread between the order of cement within what in that company or in that year 2022. That was the distribution of orders. Average spread in the amount of what orders that year. So the average spread, that's the standard deviation. Then let's look at B3. B3 is saying that Tash's disease is a real fatal genetic disease occurring chiefly in children, especially of Jewish or Slavic extraction. Suppose that we limit ourselves to families which have exactly 3 children, B, which have both parents carrying the Tay-Sachs disease. For such parents, each child has an independent probability of 1/4 of getting the disease. Let X be the random variable representing the number of children with the disease. Derive the probability distribution for X and state all possible values of X. Find the expectation and variance of X. That is it. So Tay-Sachs disease is a real fatal genetic disease occurring chiefly in children, especially of Jewish or Slavic extraction. Suppose that we limit ourselves to families which have exactly 3 children and B, which have both parents carrying the Tay-Sachs disease. So we have only 2 families, one of these. For such families, each child has an independent probability of what? 1/4 of getting the disease. So either he gets or he doesn't get. Let S be the number, the random variable representing the number of children with the disease. So what distribution will you be getting? So here you are talking about a binomial distribution, which is 1/4, because you are telling the event the probability is independent and they are the same in any of those families. So you only have to randomly sample the people. So they have a probability distribution. So X should be what? Your binomial distributions, which has a probability of getting a disease in the in those families as 1/4. And we have been told that they are independent. So if you sample 20 children from these two families or 100 children from these two families, then the chances that a child will get the disease is 1/4. So that's your probability. Is that okay? And if you have to find what your expectation and variance, then you also know how to find that. Is that the number times what X? And that is all. So if you know the distribution, you only state the expectation for that family, and that is all, the expectation for that distribution. Is that okay? And your possible values will be 0, 1, 2, 3, 4, up to n. So if you take a sample of 1,000 or 100 n, then what? Some is not everybody in those samples will get a disease. Is that okay? Some may get, some may not get, and chances of getting is 1/4, which is independent of the other. So that is your A. B, given that 0.04% of vehicles break down when driving through a certain tunnel, find the probability of A, no vehicle breaks down in an hour between 2,000 vehicles. When 2,000 vehicles enter the tunnel, at least 2 vehicles break down in an hour when 2,000 vehicles enter the tunnel. So here, what you need to do is to use the binomial approximation to Poisson to be able to solve this problem. So what you need to do, the total number of vehicles in the first case are 2,000, which are within what? 1 hour. So you multiply 2,000 times 0.04, and that will give you your lambda. Then you apply the probability that no vehicle breaks down. That's all. X will now be equal to 0 using the Poisson distribution. So your Poisson distribution, your lambda will now be 0.04% divided by 100 times 2,000. Remember, it is 0.04%. So it's 0.04 divided by 100 times 2,000. So I have this like this. Then I multiply 0.04 times 20. That will give me my rate. So you are now going to use the Poisson, which is what? Lambda to the power x e to the minus lambda over x factorial. Here your x is equal to 0 because no event, no vehicle. X equals 0. Then you calculate your what? Probability. Then at least 2 vehicles. So it's either 2, 3, or 4. So it's the same as 1 minus 0 or 1 vehicle, which breaks down within the tunnel. And that will give you your probability for II. So that will bring us the N to B for B3. Then we also find out with B4, which says that an examination consists of multiple choice questions, each having 5 possible answers. Suppose you are a student taking the examination. You reckon you have a probability of 3/4 knowing the answer to any question that may be asked. And that if you do not know, you intend to guess an answer with a probability of 1/5 being correct. What is the probability you give the correct answer to a question? What is the probability you give that you give a correct answer to the question? So here we have a multiple choice questions, each having 5 possible answers. Suppose you are a student knowing that right taking the examination. You know that the probability of you have a probability of 3/4 knowing the answer to any question that may be asked. So you don't know the ones you don't, the chances that you may not know the answer is what? 1/4. Also, if you do not know, you intend to guess an answer with a probability of 1/5 being correct. So meaning out of 1/2/4 that you don't know, you also know that your guessing alone will give you a chances of 1/5. So what is the probability you will give that you give the correct answer to the question? So it will be 3. Chances that you get the correct answer will be 3/4. And what? Plus the probability 1/5 times what? 1/4. So you have this that will get, and what you will not get, you get to be what? 1/4 times 1/5. So that will give you a probability of what? Giving the correct answer to that. So you'll be equal to what? 3/4 plus so this is what you know. 1/4 times what? 1/5. So you 1/5% correct of this. So when you multiply, you are going to have what? 3/4 plus what? 1/20. So when you add this to that, will give the probability of getting the correct answer to any question. So Deloitte Ghana specializes in tax returns for companies and individuals in Ghana. An audit by the Auditor General presented at Public Accounts Committee in Parliament reveals that an error of 5% was made on the return submitted last year, 2023. Assuming this rate continues this year, and Deloitte Ghana prepares 90 tax returns to the Audit General. How can you characterize this as a binomial experiment? So how will you categorize this as a binomial? So you know that the probability of error of each tax of getting a decision is constant throughout. So the probability of error that being found in any sample will be what? 5%, because you have been told that the audit by the Auditor General presented a public account that reveals that an error of 5% was made on the return submitted last year. So you know that for the 90% tax given, you are sure that 5% will be an error and the remaining 95% will not be an error. So you have two possible outcomes. When you pick any of these things, you have the chances that 5% will be an error, submitted an error, while 95% will not. So that is the P. Then here you have been given 90%, 90 tax returns. So N is your 90. And the third one is also, before you cut is that what? N equals to 90. And 3, each tax return is independent. We assume that they are independent of the other. The summation of each tax returns is so independent of the other. So all the 90 tax returns are independent of each other. Then the error is constant in each of them. The chances that each returns will show error is the same. That's 0.1. That's 5% for that. If you're able to do that, then you can now write your binomial. You can characterize as a binomial experiment with listing out the independencies, the possible outcome, that's an error and not an error. Then the constant nature of the percentage of an error and the percentage of not an error. Then the probability of an error and not an error, and the two possible ways. And the values, we take values 0, 1, 2, 3, up to what? 90 as what? The number of possible returns that will exhibit an error. Then 2, state the probability mass function and explain each term. So the first one, you only state those conditions for binomial experiment. Then 3, you now state the probability distribution function, that probability mass function. Then 3, what is the probability that the company makes more than 4 errors? So you have to find the probability that the company will make more than 4 errors, which is the same as 1 minus the probability that it will make less than 4 errors. That would be 0, 1, 2, 3, 4. So that will subtract that from the probability from 1, and that will give us our answer. So that is for the questions for last year. Sure, I'll share the questions with you, please. I'll do that. Kwame. So I wanted us to look at doing these ones too as well, section B part, before we close. Or are we tired? The section A is just like what we just did. So the section B is also, let's only discuss that, then we go. Are we okay? Aida, what are you saying? Are you tired? No, you're not tired, eh? Okay, so we discussed that section B, then we close. Okay, thank you. Okay. Then this was 2021, 2022 questions. Okay, so let's so I'll share this with your class rep as soon as the recording too as well. So here too, we have to answer only 2 questions out of 5. Yes, what is important is that what you don't try to look for difficult question to answer. Section B, make sure you only deal with the easiest question as best as you can. Is that okay? Look for the easy question. So when you're answering exam question, make sure you go through the section B, then you select your question, the easiest one, then you attack it. Because all of them carry equal mass. Okay, so B1, suppose a machine shop orders 500 boots from a certain supplier. To determine whether to accept the shipment of boats supplied, the manager of the shop randomly selects 12 boats. If none of the 12 randomly selected boats is found to be defective, he concludes that the shipment is acceptable. If 10% of the boats in the population are defective, compute the probability that none of the selected boats are defective. So in this, we can solve it in two ways. One, we can assume that what the sample being selected follows a binomial distribution because it is relatively small with respect to the larger sample. Then we use the binomial to solve it, or we use the hypergeometric to solve that. So here, we assume binomial, so your n is equals to 12 and your p is equals to 0 point what? 1, that's 10%. So you have your x follows binomial with n equals to 12 and p equals 0.1. So from here, the probability that is now, the probability that x is equal to 0 will simply be equals to 12 combination 0, 0.1 to the power 0, then 0.9 to the power what? 12. Is that okay? So this will give us the probability that none is what? Defective. So just that's what, with the question, that's what we need to do. That is all. No, Ebenezer, please, you don't need to answer more than 2. Sometimes a good lecturer may select the good ones and mark the best and mark. Some wicked lecturers or some lecturers who are also difficult to this thing also make him annoyed. We only look for answer, mark the first 2 questions and leave the rest. So it will be very good you obey the instructions. Instructions is also obeying the instruction is also part of the examination. So I will not advise that you solve as many. No, don't waste your time but rather take your time, go through the question and select your best question. When they give you the question paper and they ask you to preview whilst waiting for you to start, this is the time for you to go through the section B and look at the ones that you think are easy for you to answer and select them down. And always start with the easiest questions. Don't start with the difficult one. Because if you are able to start with the easy one and able to do it and do it well, you have more confidence and more knowledge to tackle the difficult one. But when you start with the difficult one and you couldn't solve it, then your whole day will be what? Destroyed. Will be what? Becomes what? Confused and you can't do anything. So always make sure that anytime you are tackling writing exam, start from the easy ones. If you're able to solve the first question and you are confident, your confidence will increase and able to target the remaining ones. Is that okay? And you're able to make use of time as quickly as possible. So B, a blood test indicates the presence of a particular disease is 95% of the time when a disease is actually present. The same test indicates the presence of the disease as 0.5 when a disease is not present. 1% of the population actually has the disease. Calculate the probability that a person has the disease given that the test indicates the presence of the disease. So here, I will advise that you draw your tree diagram as we always start like this. Yes, the 1% of the population have the disease. So this is the percentage the disease, not the disease. So this will be what? 0.01. That's 1%. And this will be what? 0.99% of the population who does not have the disease. Then, if the person has there's the probability that if he has the disease and tested that it was 0.1 positive is 0.95. Then negative will be what? 0.5. Then here, false positive. If the person don't have the disease, he can be tested positive as have the disease. That's positive. That is 0.5. If he doesn't have if he tested negative, that will be 0.95. Sorry, 0.05. Okay. Here it is 0.05. Okay. So the question says that calculate the probability that a person has the disease, given that the test indicates the presence of the disease. So the probability that a person tested positive, is that okay? Given that the person has the disease, that is it, given that the person tested positive. So it can be that the person, those who tested positive, those who didn't have the disease also tested positive, and those who have the disease also tested positive. So we are going to apply the Bayes theorem, where the numerator will be tested positive. No, those who have the disease times the probability that he tested positive, given that he has the disease, divided by he has the disease times the probability that he tested positive, given that he has the disease, plus the probability that, so the numerator will be the probability of D, which is 0.01, times the probability that he tested positive, given that he has it, that's 0.95. That will be the numerator. So 0.01 times 0.95. That will be your numerator. Then your denominator will be this probability, which is the numerator, 0.01 times 0.95 plus the person tested positive and doesn't have it. That's 0.99 times 0.05. So the probability that the person has the disease, given that he tested positive, will be equal to 0.01 times 0.95 divided by 0.01 times 0.95 plus 0.99 times 0.05. So it will be this times this plus this times this. That will give the denominator. And the numerator will only be this times that. Okay. So I hope this one too is okay. Okay, yes. Okay. Oh, sorry. Thank you. It's 0.005. Thank you instead. I'm grateful. So it's 0.5%. So that will be 0.005. Stranger, thank you very much. Yes, Kwame, you can drop the tree diagram in the answer. in your answer booklet. It doesn't spoil anything. Is it okay? You can draw it there so that you can able to pick the probabilities. That's fine. So thank you. Thank you for the corrections. So please take note. It's 0.005, not 0.5. I'm very, very grateful. Okay. So let's look at the third one. Here, suppose that y is a discrete random variable with the probability mass function given as this. Is 1 over 6 for k equals 0, 1 over 8 for k equals 1, 1 over 6 for k equals 2, 1 over 8 for k equals 3, 1 over 4 for k equals 4, and 1 over 6 for k equals to 5, and 0 otherwise. Compute the cumulative distribution function of y and sketch its graph. So here we are to find the cumulative distribution function. So we'll start for less than 0 will be 0, 0 for k less than 0. It will be 1 over 6 for k is greater or equals to k but less than 1. K is greater or equals 0 but less than 1, 1 over 6. Then 1 over 6 plus 1 over 8. So 1 over 6 plus 1 over 8 will be for k that is 1k. When k is greater or equals to what? Less than 2, greater than 1, greater or equals to 1 but less or equals to 2, we have 1 over 6 plus 1 over 8. Then we now go to add this to the next one, 6, until you get to the last one. The last one will be 1 for k greater or equals to 5. So we have to add all of that. So when we finish, then we come to and draw our distance. Then you have 0, we have 1, we have 2, we have 3, we have 4, we have 5. So at 0 is what, 1 over 6. Then it comes to 1, it moves up. Here it will be like this. Here will be what? Then you come to the next one, then it moves like this. So the 5 will be the last one like this. So this is what you are supposed to get as we learn how to sketch the cumulative distribution function. Are we okay with that? Okay. Then if a new random variable y is defined as x equals to y minus 1 squared, then state the values of x. So here you don't have any problem. Where you see x, oh, yeah. Sorry, it's supposed to be y equals to x minus 1. Is that okay? X minus 1. So you have here, when x equals to 0, k equals 0, so you have k, 0 minus 1 squared. K equals to what? 1, so you have 1 minus what? 1 squared, that will be 0. Then you also continue. Okay, yes. Here should be what? Y. And here should be x. Here should be y. So it's the other way around. Sorry for that. So assuming these are your K values. Is that okay? So you have K minus K equals 0, then substitute K here. Then whatever you can write it down. When K equals to 1, you put it here, you square it, you simplify, you square it. When you finish, that is all. Then you list those values, and that becomes what? Your values of your X that we have over here. So you only substitute K equals 0, 1, 2, 3, up to 5 into this, then solve. If you get two values like here 0 minus 1, it give you -1 squared, that will give you 1. Then when K equals to 2, 2 minus 1 will give you 1, 1 squared will give you 1. So it will give you the same value. So you have 0, 1. If you have 4, because and you have 9, and you have 16, those will be the values of your random variable, a new random variable. Is that okay? Sure, thank you. So here there was a typo there. So B, the number of emails received in a day can be modeled by a Poisson distribution with a rate of 0.2 emails per minute. I, determine the probability that one receives no emails in an interval of length 5 minutes. 2, what is the probability that one receives more than 3 emails in an interval of 10 minutes? One receives more than 3 emails in an interval of 10 minutes. So first, B2A, we are dealing with Poisson distribution. Remember, we have been told that our emails are written per minute. So the rate is 0.2 per minute. So now, if we have to find in the interval of 5 minutes, then we have to convert our rate to 5 minutes. So what do? We multiply 0.2 by 5. That will give us per 5 minutes. Then use that to calculate your probability. So for yi, your new lambda will be equal to 0.2 times 5. So then you apply the probability that no emails will be revealed. So your X will be equal to 0. So your probability of no email will be equal to lambda, which is what? 0.2 times 5. So lambda to the power 0, e minus lambda over 0 factorial. Your lambda is 0.2 times 5. And 0 factorial equals to 1. So 1 times e to the power minus 0.2 times 5 over 1. So that will give us the answer. When it comes to the second one, what is the probability that one receive more than 3 emails in an interval of length 10 minutes? So here we also have to calculate our new lambda, which will be what? 10 times 0.2. So that will be a new rate. So more than 3 emails. So it should now be 1 minus the probability that X, the emails is less than what? 3. Because calculate the probability from 0, 1, 2 is easier than calculating from 3 to infinity. So you calculate the probability at 0, the probability at 1, probability at 2, and subtract it from 1. That will give us our second question, II. And here our lambda will be 0.2 times 10. 0.2 times 10. Okay, that will be 2. Then let's go to B. B says an accountant has found that 9 out of 10 company audits contain substantial errors. 9 out of 10 company audits contain substantial errors. If he audits a series of company accounts, what is the probability that One, the first account containing substantial errors will occur on or before the third audited account. So here we are dealing with what? Geometric distribution. So your probability of what? Error will be what? An accountant has found that 9 out of 10 company account audits contain substantial error. So 9 out of 10. So 9 over 10. So that's the probability. P equals 9 over 10. That's 0.1. 0.9. So that is what will be our probability that will help us to calculate that. So now, if the audits, if he audits a series of company accounts, what is the probability that the first account containing substantial errors will occur on or before the third audited account? On or before. So it means that it can happen on the third one, or the first one, or the second one, or the third one. So we have to find the probability that x is less than or equals to 3. And x follows a geometric distribution with probability of 0.9. Is that okay? So we know it will be what? The probability distribution giving p 1 minus p or q to the power what? X minus 1. So when p equals to this, so you always have to, when s equals to what? 1, 0. When is s equals to 1, so you have 1, 2, this thing, 1, 2, 3. When s equals to 1, then you have a p into 1 minus p to the power what? If it happens on the first one, then there will be no failure. So you have p times 1 minus p to the power what? 0. Or if it happens on the second one, it will be p into bracket 1 minus p. If it happens on the third one, it will be p in times 1 minus p to the power 2. So you add all the three, and that will give you your probability for I. The first account containing substantial errors will occur on or before the third audited account. So either the first one, the second one, or the third one. So that is what we stated the probability here. And this is your distribution. P into bracket 1 minus p to the power x minus 1. So we find x equals to 1, s equals to 2, and x equals to 3. Into this, then add all of them. We know our p equals to 9 over 10. That is what? 0.9. And 1 minus p is 0.1. Okay, then 2. What are the mean and variance of the number of accounts that must be examined to find the first one with substantial errors? So we have to find the mean and variance. We know that when x follows a geometric distribution, the mean is 1 over p, and the variance will be what? Q over p squared. Q over p squared. So your mean, the expected value of x, you said it equals to 1 over p. And your p is 0.9, or that's 0.9. So you find the reciprocal of that. That will be what? 10 over 9. Then your variance is equals of x is equals to q over p. Over p squared, so yeah, q over p squared. And q is 0.1 and p equals 0.9. So that will give you your variance. If we know this, we don't have a problem. Okay, so our question BII is also solved. Then we go to C. According to a Gallup poll, 60% of American adults prefer savings over spending. Let X denote the number of American adults out of a random sample of 50 who prefer savings to spending. What is the probability distribution of X? Find the probability that more than 30 adults prefer savings. So in the first one, say 60%, a Gallup poll, 60% of American adults prefer savings more over spending. So let us know the number of American adults out of a random sample of 50 who prefer savings to spending. So since it's a random poll and a random sample, each individual selected is independent of the other. So in that way, independence is all established. So the events are independent. And we have a fixed number for sample, that's 50. And the third one, the probability of a success is 0.6. So that means it's a binomial distribution. So what is the probability distribution of X? So X follows a binomial distribution. Then you have to state the distribution. Your P equals 0.6, your N equals 50, and you state your Q equals what? 0.4. Then write it here for us, the probability distribution. That is our binomial with N equals to 50 and P equals 0.6. Please remember to do that. Then find the probability that more than 30 adults prefer savings. So we have to find the probability that X is greater than what? 30. If you think it's too big, you can use the approximation to be able to do that. Then that brings us to the end of B2. Then B3. A discrete random variable X has its probability mass function given by Kx by X squared plus 1, where X equals to 2, 3. 2K times X over X squared minus 1, where X equals to 4, 5. Or elsewhere. Find the value of K, the constant K. So here we should know that what? The summation of probability of X should be equals to 1 for all values of X. So now when you put X equals to what? 2, what will you get? So you have 2K over 5. Then plus when K S equals to 3, so I have 3K over 3 squared is 9 plus 1, 10. Then I have plus 4. When I put 4 there, then I have 4 times 2. That will give me 8K over 4 squared is 16 minus 1, 15. Then I have plus 5 times 2. That will give me 10K over 5 squared is 25 minus 1. That will give me 24. So you add this plus this plus this plus this equals to 1. Then you solve your K. Then we can get a value of K. So you add 2K over 5 plus 3K over 10 plus 8K over 15 plus 10K over 24. All equals to 1. So with that, we can get a value of K. Then now if you get it, then sub the value of K into this, then get your new probability mass function. Then I find the probability that X is less than 3 or greater than 4. X is less than 3 or greater than 4. If x is less than 3, then you're looking for when x equals to 2. Or greater than 4, then when x equals to 5. So you find the probability that x equals to 2 or x equals to 5. Then you substitute that in place of what? This and this one. And if you know the value of k, then you can easily calculate those probability, and that is all. Then calculate the variance. Since we know k, then we can easily calculate the expected value of x and the expected value of x squared, and that'll give us the variance. How we can do that? Okay. Then the B part, that is also a binomial problem. You take an exam that contains 20 multiple choice questions. Each question has 4 possible options. You know the answer to 10 questions, but you have no idea about the other 10 questions. So you decided to choose the answers randomly. Your score X on the exam is the total number of correct answers. To find the probability mass function of X. And what is the probability that X is greater than 17? So here, your probability mass function of yes, knowing the correct answer for the first one is 1 out of 5. So 1 out of what? 4. So your P is 1 out of 4 and your N equals to what? 20. So it's a binomial distribution. So find the probability mass function. So you know that this is a probability mass distribution where your P equals 1 over 4 and your N equals what? 20. Then what is the probability that S is greater than 17? So you only have to calculate, you know that from 0 to 10, you have 50% of getting the correct answer. Because you know that. So that is what? 0.5 plus the probability that this thing S greater than this thing. That's getting all correct answers. So you can just calculate the probability S is greater than what? 17. That S is greater than 8. That's 18. S equals 18, 19, or 3. Into the binomial distribution, and we can get our answer. As simple as that. So here, our probability of S equals to X will be equals to what? 20 combination X, 1 over 4 to the power X, 3 over 4 to the power N minus X. N equals to 20, so you can put 20 years. Where your X takes value 0, 1, 2, 3 up to what? This is 20 minus X. So here, greater than that means you have to calculate the probability at S equals 18, S equals 19, S equals to 20, and that'll give you your probability. You add all the three. S equals to 18 plus S equals 19 plus S equals to 20 will give you the probability now of this one. So this is the answer to this one. And this one, we now substitute S equals to 18. S equals to 19, S equals 20, then we solve for, add all the three, that will give us the probability that S is greater than 17. So C we have a table given to us here. The table represents the heights in inches of a sample of 10 male semi-professional soccer players. So these are the heights These are the frequencies. These are the relative frequencies. Okay. Determine the percentage of players whose heights are between 67.95 and 71.95. So you go to your table and locate 67.95. I have 67.95 here. And also my 71.95 is also here. So what do? I add these two relative probabilities. Relative frequency. That will give you this probability 1. So if you add 0.17 plus 0.12, it will give me the probability between for the first one. Yes, I'll make the files available. Yes, I'll make it available. No problem at all this evening. So don't worry. Then to II, what is the probability that the player height is more than 65.95 inches? So 65.95 inches, that would be from here. No, 65, yes. 0.95 inches from here to the top, to the last one here. So you have to add all the probabilities from 0.40 to 0.1. So when you add, that will give you the probability that he has a height more than 65.95 because it ranges from 65.95 to 67.95. So you start from there to the end, but more than, so you start from 0.40 to 0.1. So you add 0.40 plus 0.17 plus 0.12. Remember, this is what we are using continuous or interval. That is why where this one ends, this one starts from there. That is why we are starting from this one and not here. If you start from here, you have missed this interval. So we are starting from 65.95 to 67.95 because of the class boundaries. Okay, so you add 0.40 plus 0.17 plus 0.12 plus 0.07 plus 0.01. That will give you that probability for II. Okay, then finally, this is also a question that we can easily solve without difficulties. So we go through that, then we end that. So now a major financial institution in Ghana thoroughly investigates its applicants for small and medium enterprises loans. Hence, it has an impressive default rate. The probability that an SME loan will be in a default is 0.005. The bank has approved 200 SME loans for the current financial year. Assuming the Poisson probability distribution applies to this problem, write down the probability distribution for this case. So here, you are going to use your binomial approximation to Poisson to be able to write this. So here is the probability of default, 0.05. And the other component will be not default. So you are going to find the lambda, which equals to 200 times 0.005. I'll give you lambda. Then it will help you to write your Poisson distribution. So the lambda equals to 200 times 0.005. Then show that it is a legitimate probability mass function. We learned that how to prove of Poisson, so you can also do that as well. So now see what is the probability that no SME loan will be in default. So here your S equal to 0. So you have to, we know our Poisson, probability that X is Poisson will be equals to lambda to the power x e minus lambda all over x factorial. So here your x equal to 0. No, what's the probability that no SME will be at default? So your x will be 0. Then calculate that probability. Lambda equals what? 200 times 0.005. Then D, what is the expected number of loans, SME loan, that will be in default? And what is the standard deviation? We know that when X follows Poisson, your mean equals what the rate and your variance also equals the rate. So your mean will be 200 times 0.005. And the square root of that will give you your standard deviation, as simple as that. So D2 is done. Then what is the probability that 3 or more SME loans will be in default? So the last one, E, we have to find the probability that X is greater or equals to 3. And it's the same as 1 minus the probability that X is less than or equal to 2. So we calculate this with the Poisson rate as this. Then we subtract it from 1, and that'll give us that probability, as simple as that. Okay. So that brings us the end of B4. And thank you very much. Yes, thank you all. I'll make the file available. I'll share it with your class rep as soon as we end the class so that he can share with you. And as soon as the video too is ready, I'll also share it with you. The audio is ready.